All right, everyone, in this video, I want to stress the importance of, in physics, being able to manipulate equations for certain variables in those equations without plugging numbers in. A lot of students struggle with this in the beginning. They are used to, in their math classes, plugging in numbers and then solving for X or solving for Y. In physics, especially advanced physics, you want to get away from that. You want to be able to manipulate, for reasons that we'll definitely go into in the future, you want to be able to manipulate equations without having to plug numbers in. And so that's what your first real media assignment is actually going to have you do. You're going to rearrange equations for certain variables within those equations. Now, to do that, I'm going to show you some examples. I'm going to give you some tips. And the most important tip that I can give you is it's not a tried and true rule. It's not going to work 100% of the time, but almost every single time it will work. When you're manipulating these equations, what you want to do is think of doing PEMDAS, something that I know we're all familiar with, but we're going to deal with PEMDAS in the reverse order. So if we're solving an equation for a certain variable, it really makes sense to do any addition or subtraction that you need to do first, to do the multiplication and the division next, and then finally deal with parentheses and or exponents. Okay, so think reverse PEMDAS when you're dealing with this kind of thing, and it will make your life a little bit easier. All right, so what you see up here are three equations that we're going to solve for certain variables. These are three physics equations. You will realize in physics, equations aren't just letters written down. The letters actually represent physical quantities. And so when I go through these three examples, I will actually tell you what these equations mean in words. And we will see some of these equations throughout this year in your AP Physics course. So the first example we're going to do, and I know there's some glare issues. Sometimes I will be doing these videos digitally on a digital pen tablet, but I wanted our first real media assignment video to have my face in it so you can kind of get to know who I am if you've never had my classes before. So the first problem here, the first question, we have this equation here. Capital F equals lowercase q times capital E. This equation says that the electrical force on a charge is equal to that charge's charge, the actual quantity of that charge, times the electric field. E stands for electric field, Q stands for charge, F stands for force. For those of you that have had some experience with physics, you might recognize this equation. This is Newton's second law in an equation form. The force is equal to mass times acceleration. These are very similar types of equations, but this is going to be your electric force equation instead of just normal force equation. And if you see here, we have this equation, we're told to solve for E, solve for the electric field. Well, remember, we're thinking PEMDAS, but we're thinking PEMDAS in reverse order. So in order to solve for my unknown, which are the variable in question, which is E here. To solve for E, I'm going to first do any addition or subtraction that I need to do in order to get E by itself. I don't see any pluses or minus signs, so we actually don't need to do any addition or subtraction. Then we're going to do any multiplication or division to try to get E by itself. And I do see multiplication here. I see that the electric field, E, is multiplied. It's multiplied by the charge Q. So in order to get E by itself, I have to do the opposite. I have to undo that operation. And to undo that operation, I divide. We have multiplication, I do the opposite. I divide both sides by Q. Why do I divide both sides by Q? Well, Q over Q makes a ratio of 1, which means that those will cancel out on the right side. And I then have, in my next step, I like working down as I solve equations. I have force divided by charge equals electric field, or the electric field equals F over Q. Now, I tend to like things that I'm solving for to be on the left side, so I would actually rewrite this as E equals F over Q. and then I box my answer. Always box your answers. That's a good habit to get into. And there I got my first problem done. Notice I didn't have to deal with any exponents or parentheses. All right, let's move on to example problem number 2. Example problem number 2 is the following equation. I have x equals x with a subscript 0. We pronounce this x naught, N-A-U-G-H-T. It's another way of saying 0. So x equals x naught plus v with a subscript, that's pronounced v naught, times t plus 1/2 a t squared. Now, what do all these symbols mean? X is final position of an object. X naught is the initial position of an object. V naught is the initial velocity of the object. T is time. 1/2, you might know what that is. A is acceleration, the rate at which an object is speeding up or slowing down. And T is, again, time. Notice we do have some additional information here. We have V naught equals 0. Which means that the object starts from rest. It starts with 0 velocity. It starts from standing still. Now, since V naught is 0, I know that 0 times time, whatever time is, it could be a billion years, it could be a second, doesn't matter what it is, 0 times that time makes 0. And so what I like to do is just remind myself that this whole quantity here, that product is 0. And mathematicians and physicists tend to do this. They put a little line through it and they write 0 there just to remind themselves that they can kind of ignore that. Now, to keep myself neat, I'm rewriting this equation without doing anything else. I'm going to rewrite it. I'm going to say x equals x naught. I can drop this quantity here. So I'll just have x equals x naught plus 1/2 a t squared. And again, we will be doing a reverse PEMDAS. So I'm going to be thinking of doing PEMDAS in reverse. I'm going to take care of any addition or subtraction I need to take care of in order to get, our unknown is t. We want to solve this for t. Is there any addition or subtraction that I need to do in order to get t by itself? There is. X naught is being added to 1/2 a t squared, so I must subtract it to get it to the other side. Again, you always do the opposite. So I will be subtracting x naught from both sides. Obviously, x naught minus x naught is 0, so those go away. On the left side, I have x minus x naught. Those are not like terms, so we can't just combine them. So we say that that's x minus x naught equals 1/2 a t squared. Is there any addition or subtraction on the right side that we need to take care of before we can actually get t by itself? The answer is no. All I have is multiplication or division. Okay, so to get t by itself, I have multiplication by a and multiplication by 1/2 or division by 2. Those are the same thing. And I'm going to do this the long way. I'm going to do it one step at a time. I'm going to do the 1/2 and the a. I'm going to deal with those separately. So when I look at this, I don't like fractions. If I can get rid of them, I do. So how do I get rid of this fraction? I have essentially this quantity divided by 2. So I just multiply both sides by 2. Be sure that that 2 distributes over x minus x naught on the left side. You can't just put it right in front of the x because it's got to multiply by this whole thing. So you got to put that in parentheses. A lot of students like putting it like this, putting it over the ninja one, the invisible one, so that it reminds them that you have a numerator 2 and a denominator 2, and those again make a ratio of 1, therefore they cancel out. And since I'm running out of room, I'm going to bring the rest of the problem over here. And then I'm going to, again, rewrite. It keeps you neat, keeps you from making those little silly mistakes. So on the left side, I have 2 times the quantity x minus x naught. And that will be equal to, what do we have left over here? Well, all I have is a t squared. All right. Do we still have some additional multiplication and or division? Yes, we do. T squared is multiplied by a. So I need to do the opposite, just like we did in example 1. I'm going to divide both sides by a. Again, a divided by a, ratio of 1, those go away. And then what am I going to do again? I'm going to rewrite. So I'm going to have 2 times x minus x naught divided by a is going to equal t squared. Now to get t by itself, it's not by itself, but to get t by itself, I have no more multiplication or division. So now I'm going to move on to the e, which is exponents. Do I have an exponent to deal with? Of course I do. I have t squared. So what's the opposite of squaring something? Well, it's taking the square root of that thing. So now I'm going to take the square root of both sides. So on the left side, what I end up with, and you can't simplify that anymore. You can't, there's no terms to combine, like terms to combine, nothing like that. So what I'm left with is the square root of 2 times x minus x naught divided by a. And what's the square root of t squared? Well, the square root just undoes t squared. So then we end up with t. And again, if this was my assignment and I was doing this on paper, I would write another step t equals this, but I'd put the t on the left side. But because I'm out of board space, I'm just going to leave it like that. And you can leave it like that as well. I would never take points off if you left it like that. Okay? All right, so that's example number 2. Now, what does this equation talk about? Well, I already told you what this equation talks about. Now, one thing I do want to stress, I want to at least point out, we'll see this starting very soon, actually. I told you before, this is final position, like the final position that an object ends up at. This is the initial position. Now, you might know, so this is just an aside, you don't need to put that in this particular problem. But anytime you have a final something minus an initial something, that is change in something. And change in something we can write as the delta. So these two things mean exactly the same thing. Delta x is the same thing as x minus x naught. So I could have put 2 times delta x over a and the square root of that in my answer instead. Again, either way is actually correct, so that's fine. Either way is fine. All right, let's do our last example here. Our last example, one of my favorite equations, capital F equals capital G times M1, M2 over R squared. And this one we are told to solve for R. Now, when you solve for a variable that's in the denominator, I can't tell you in AP Physics 1 or AP Physics C, even my brightest students sometimes mess this up. Students tend to not like solving for variables in the denominator. So pay close attention because we got to deal with this with a little more care than some of the other examples and some of the other problems that you'll see on your worksheet. What is this equation? It's actually Newton's law of universal gravitation. Newton figured this out in the 1600s. F is gravitational force. Big G, talk about that in a second. M1, M2, that's 2 masses. So this equation could determine the force of gravity between, say, the Earth and the Moon, or the Earth and the Sun, or the Sun and the supermassive black hole at the center of the Milky Way galaxy. Right? Any 2 objects in the universe will have gravitational forces on each other, and we can calculate them using Newton's law of universal gravitation. Big G, it's called the gravitational constant, the universal gravitational constant. The story of the measurement of that value is incredibly interesting, and we'll actually talk about that this year. A guy named Henry Cavendish, one of the most interesting scientists of all time, he actually measured that in the 1800s, late 1800s, using a very ingenious experiment that we'll talk about later in the year. But let's just go ahead and focus now on calculating or solving this equation for R. Okay, first of all, I noticed that R is in the denominator. First of all, actually, I realized that there's no addition or subtraction needed to happen here. Everything's multiplication or division or exponents. So we don't need to worry about addition or subtraction. So I'm going to go ahead and jump into multiplication and division. But anytime your variable in question is in the denominator, you got to get it out. You got to get it out. So I need to get R squared out of the denominator. How do I do that? I multiply both sides by R squared. So I'm going to multiply this side by r squared, and I'm going to multiply this side by r squared. Again, a lot of students like doing it like this, putting it over the ninja one so they see explicitly that I have a numerator r squared and a denominator r squared, so those will cancel out. So I'm left with r squared times f equals big G times m1 times m2. Now I still have some multiplication or division to deal with. I have r squared multiplied by f, so in the next step I'm going to divide both sides by f. Again, we do the exact opposite, the opposite operation. Numerator f, denominator f, those will cancel. And so now what I'm left with is r squared on the left side equals big G times m1, m2 over f. Now I'm done with all the multiplication or division. Now I just need to deal with the exponent in the same way that I dealt with the exponent last time. I'm going to square root both sides. And the square root of r squared is obviously, let me follow this up here. The square root of r squared is r. And there's no way of simplifying this, so that's my answer. The square root of big G times m1, m2 over f. And there's my answer. So there's 3 examples. And what I feel like is the most useful tip for this kind of stuff is reverse PEMDAS. You do that 99 times out of 100, it won't lead you astray. And just so you know, we're going to be doing this all the time. We're going to be rearranging equations all the time. In fact, on the AP Physics exams, both 1C and 2, which we don't offer at this school, chances are if you have a calculation question, whether it be multiple choice or free response, chances are there's going to be no numbers to plug in. So you're going to have to know how to do this. You have to know how to manipulate equations without plugging in numbers. Okay, that's the big takeaway here. Hopefully these 3 examples helped you. You'll get some practice with the worksheet. Please jump on my Zoom meetings if you have any questions about any of those problems. I will happily walk you through them and give you any more, give you some more help if you need it. All right, that's about all.